Okay, this is probably my favourite question in the whole course, and we do it in exactly the same way, but we're just going to find that the algebra in this gets a little bit more complicated as we work through it. Okay, so I've got my reaction force A, and I've got my frictional force A. I know that the frictional force is 0.4 times the reaction force. I've got my weight down here, which is 20g, at a distance of 2 meters, and a further meter on, I've got my reaction force, which is going to be perpendicular. This angle here is A, and I know that this angle here is also A. So I can decompose while I'm doing this to say that this is, if this is R, this is going to be R cos A, and this one's going to be R sin A. So we're going to start with our moments about A. So let's do moments clockwise about A. So my distance here is going to be cos A times 2. So it's going to be 2 cos A times by 20g. That's my clockwise moment, is equal to, let me just write on my additional meter, sorry I forgot to put that on, there's another meter here, it's going to be 3 meters times r. Okay, we're not going to do anything more with that at the moment, we'll come back and have a look at how to use it in a second. We're going to resolve, let's resolve vertically first, and resolving vertically I've got RA plus R cos A equals 20g, and resolving horizontally I've got FA equals R sin A. We also know that from the question here, FA equals 0.4 RA. I'm going to put that as a fraction, equals 2/5 RA. So I'm going to use this equation here, my coefficient of friction, to get rid of FA. So I can say, therefore, 2/5 of RA equals R sin A. I can now use this to get rid of RA up here. So RA is equal to 5R sin A over 2. So substituting in, I've got 5R sin A over 2 plus R cos A equals 20g. Now, this has left me, I've used all of this stuff, so I've been left now with 2 equations, 1 and 2. So those are my 2 equations. Both of them involve R and my angle A and no other unknowns. I'm only interested in the angle, so I'm going to rearrange 1. So here, multiplying this out gives me 40g cos A, so I can say rearranging 1 gives me R equals 40g cos A on 3, and I can then substitute that in. So I've got 5 sin A over 2 times by R plus R cos A, so plus 40g cos A on 3 times cos A equals 20g. A couple of things come out quite nice and easily, so I can divide everything by 20g, so that's going to be a 2, that's going to be a 2, that's going to be a 1. So I've got 10 sin A cos A on 6, smooth this down a little bit, plus 2 cos squared A on 3 equals 1. I'm going to multiply everything through by 6, gives me 10 sine A cos A plus 4 cos squared A equals 6. Now, the easiest way to do this is a lot of different ways, and a student of mine was very impressive in demonstrating this as the easiest way, is to divide everything through by cos squared A. Now, here I'm going to be left with cos divided by cos squared, so I'm going to be left with cos A on the denominator. Sine A of cos A is tan A, so I'm left with 10 tan A plus 4 equals 6 sec squared A. Divide everything by 2 here just to make life easier for yourself, so 5 tan A plus 2 equals 3 sec squared A. Now, I'm terrible at remembering my identities involving sec squared and tan squared, so I'm going to just go back here and write my sine squared plus cos squared equals 1. Divide everything through by cos squared. Tells me that tan squared plus 1 equals sec squared. So here I can get rid of this sec squared by replacing it by tan squared plus 1. So I've got 5 tan A plus 2 equals 3 lots of tan squared A plus 1. And then I'm left with 3 tan squared A minus 5 tan A. I've got plus 3, and then I've got to subtract my 2 plus 1 equals 0. This doesn't factorise easily, so I'm just going to put it into the polynomial solver on the calculator, and I get tan A equals 1.4343 or 0.2324. Just do inverse tan to tell me my final answer. Of 55.1 degrees, or 13.1 degrees. Just before we finish, I want to just take a look at what this means in practice. So we've got two possible values here. So if we think about what's happening when this angle is less than 13.1, my ladder is so close to being horizontal that there's very little inclination to slip. When it's above 55, it's so close to being vertical that again there's very little inclination to slip. So the dangerous place for the ladder to be will be anywhere between those two values.